At first glance, sending data as one complete piece feels like the safest and most reliable possible approach.
One message, one journey, moving directly from sender to receiver without being broken apart. But this simple approach hides a serious weakness that only appears when something goes wrong. If even a small part of that message fails, the entire transmission fails along with it. Everything must be sent again from the beginning, wasting time, bandwidth, and computing resources. On a global network, this kind of failure quickly becomes expensive and unreliable.
So the internet needed a completely different strategy for moving information.
Instead of sending one large message, the internet breaks data into many small packets.
Each packet carries only a small fragment of the original information.
No packet contains the full message or depends on the others to move forward. This single design choice changes how the entire system behaves under pressure.
If one packet is lost, only that small piece needs to be sent again.
The rest of the data keeps moving, completely unaffected by that failure. Failure is isolated instead of spreading across the entire message. This makes recovery faster, more efficient, and far more reliable.
Packets are also free to take different paths through the network.
They do not need to follow the same route to reach the destination. When one path becomes slow or crowded, packets can automatically move another way.
This allows the network to adapt constantly to changing conditions.
Packets often arrive out of order and at different times. The receiving device patiently waits and puts everything back together correctly. If something is missing, the system simply notices and responds.
Only the missing packet is sent again, not the entire message. Over time, the original message is reconstructed accurately from these pieces. This approach turns instability into something the system expects and manages. Instead of preventing failure, the internet learns how to survive it. Rigid systems break when conditions change unexpectedly. Packet-based systems remain flexible and continue operating under the same conditions.
This is why streaming, downloads, and video calls work reliably around the world.
It is also why connections can pause and resume without starting over. Packets allow data to travel efficiently across vast global distances, even when network conditions change constantly from moment to moment.
Loss slows communication, but it does not stop it entirely.
This design makes the internet resilient rather than fragile.
Splitting data into packets is not a technical detail, but a core design philosophy. The internet works because it accepts uncertainty instead of trying to eliminate it. Packets are the reason the internet can fail constantly and still keep working.